Hi, and welcome to the Pole Shift News. Guys, before we begin, big thanks to Cole. Thanks for sticking with us, and everybody else that has pledged a bit of support for the Pole Shift News and the maverickstar Observatory over the last few years. We've been here on YouTube, and more recently over on the internet. Guys, we're coming up on an anniversary. Around the 15th of next month. If you go onto Pole Shift News and look at the TriMag data page, you'll see that it was around about the 15th of May we began collecting data, and in that time we've managed to collect data nearly every 3 seconds for an entire year. It's about 9,000,000.6 individual data sets on the heading of the magnetic North Pole. Now, a little bit later on, we're going to have a look again at something that has happened recently over the last few months, and we've seen it clearly on the data that we've collected on the TriMag data, and I've got a possible theory as to what's caused it. But, as you can see, guys, we've had a bit of a facelift on the main page of Pole Shift News, and, we're going to continue going where this ever leads. It's been solely down to those people that have supported the channel over the years. Do you remember when we first started out? We just talked about other people's data and looked at other people's research. Now we're actually collecting our own data, and we've actually got an observatory that is monitoring the heading of the magnetic North Pole very accurately. And more recently, we are now focusing on the magnetosphere strength, because we know over the last 50 years at least, or within that time, the magnetosphere is depleted by around 20%. This is important to us on this planet because the magnetosphere is what protects us from all the harmful cosmic radiation, not just coming from the sun, but from outside our solar system. And when we have low yields of sunspots and low sun performance, what happens is our heliosphere shrinks, which protects the whole of the solar system. And on top of that, if we've got a weakened magnetosphere, it's only going to amplify the effects of that inbound radiation. We know now, and many of you do from other channels that have talked about it on YouTube, that this leads to cloud nuclei, and inevitably the end result of that is more vapor, water vapor and water droplets in the atmosphere. This sort of thing can make jet streams very sluggish, break, intertwine, and deliver weather that's not usually common in specific areas on this earth. So guys, just a quick look at some of the data from the 15th of the 5th last year, 2017, and just point out what we've been talking about over the last few days. Is this wavy line that we sometimes get in the data. It's graphed. When it's graphed, it shows it up even better, but when you're looking at the raw data, you're just looking at numbers that are changing around these periods of time. But you can see what we're talking about. As the months have gone on, we can see these waves are always there, and that happens up until around October the 10th last year, 2017, where the line pretty much after that month stops. And then from that month, from those months on, there's very little change in the line, which means, with our TriMag system, what that means is that the pole isn't moving westerly or easterly, or even marginally within that period of time. So, it's left us to now ponder what's caused that. Now, I've been looking at sunspot activity from around October, and this is when it really starts to drop off, and sunspots start to get scarce around that period of time. And I'll just go through a few of those months very quickly so you can see the levels of sunspots during that period of time. So we just looked at December. Was that December? I think that was October. Moving on to November. We can see again, there are a couple of sunspots throughout the month, but they're very scarce compared to what they used to be like. And I'll give you, for instance, just so that you know that these things are definitely fading out. So we're in December 2017, and you can see there is just a couple just above the equatorial region on the sun. And then February 2018, very, very few. And then, we're in April, and you can see the same story. So what I'm suggesting is that as we've had around October low sunspot yields, I think it's finally took its toll on the buffeting on the Earth's magnetosphere. And I think from what we're looking at with the data that we've collected on the heading of the magnetic North Pole, is that when we've got an active sun and there's plenty of sunspots, there's plenty of radiation blown towards the Earth, and what that does is it buffets on the magnetosphere, and that in turn moves the magnetic dipole over the northern hemisphere around in those little circular tracks that we see on some of the data sets that other organisations collect. So as it's came to a halt recently, I'm not saying that the migration of the pole at this stage has completely stopped. What I'm saying is when we look at the data and the numbers, it's saying 10.65. It's one notch away from being 11%, which means that over the year it's migrated 1 degree, which equates to about 47 miles of progression, still in an easterly direction towards Siberia. Now, I think it's only fair, after showing you, the lack of sunspots, that we have some form of comparison. And I've got a really bad example on the website, but I'll leave it up there just to show people what an active sun looks like, and I'll explain why it's a bad comparison. Because if we look at what these two photos of the sun, you can see one instantly has more sunspots than the other, and that was taken in 2000, July 19th. You can see very active sun, lots of sunspots. And then there's another one in March 2009, and I'll just explain why it's a very bad comparison, because the July 19th 2000 was taken almost at the maximum of the solar cycle, where you're going to have plenty of sunspots, and around 2009 it was a period where the sun was going towards the end of the solar cycle. So 2000 here on this chart, we can see solar cycle 23, that it's in its maximum phase, and then towards 2009 it's at its minimum. And for that reason it's a bad comparison, because you do get low sunspots at that period of time. But let's put it in perspective, okay? We can see by looking at solar cycle 22, 23 and 24 that the numbers of sunspots have been dropping off. Right, we're almost at the end of a very short solar cycle of about 9 years, as opposed to an average of 11 years. So we're at a period of time where, yes, we are going to see small numbers, if any, of sunspots right now. And I'm just saying that we've been lucky at this period of time. We haven't had to wait 11 years for another minimum to come in before we can just test what happens with our trimag system. And as the sunspots peter out, how it affects the magnetic North Pole. So this observatory has already achieved a milestone in the level of recording that we've done so far. Remember, we have a very high resolution of recording data, and although you don't see, I collect all the numbers, and it's the numbers part of the data that we can always go back on, always check the dates and even the times and even the seconds, because every 3 seconds we take a reading of where that magnetic North Pole is and we record it, and then we graph it and we put it up onto this website, and we've got an archive where we can go back on. I'll just give you an example of why I do that. If we look at, let me just get it up on this website. For some reason it's running slow. Okay, not what I want, but I want the magnetometer data. As you can see, on these magnetometer data collected by other organisations, I keep them on here. They're all measuring the nanoteslas. We measure in the microteslas. So they're measuring a lot finer detail, but over shorter periods of time. You can see on this one here, it's got April the 24th, 25th, 26th, 27th. So the data's going to be going along in 24-hour shifts. And then we've got one which looks to be measuring in hours. Again, it's measuring in regions of 20 units of 25 nanoteslas. And if we look at our magnetosphere data, we can see we're collecting over a whole period of time, almost a month at a time, archiving it. And I think you get a better picture as to what's happening. Now, can you imagine another year's worth of magnetosphere data? What we're going to be able to learn from that, and very quickly you guys can come on here and see it, and you can see what's happened in the last month with the magnetosphere, and you know whether the strength has depleted or actually increased. Now, looking at the last month worth of data, we can see it's actually gone up towards the end of the month that we recorded in strength, and there was a fluctuation, if I remember correctly, by 1.8 microteslas. Now, it's going to be very difficult to see that when you're measuring it in every hour intervals, how it's panned out over the month. And I've tried myself to get, you know, larger slots of data on other organisations' magnetosphere readings and not being able to do it. I've also, you know, tried to find another observatory that monitors the actual heading of the magnetic North Pole. Again, I've not found another organisation or observatory that's doing that. So we've got something really unique on here, and I think the way we record the data is a little bit better for, you know, looking at historically over these periods of time that we've recorded it, what has gone on. You can look at 15 minutes and then look at another 15 minutes and then look at another 15 minutes. You don't really see any big changes going on. But if you look at a whole chunk of data over a period of months, then I think there's more going on. I mean, our magnetosphere records every 15 minutes. I don't think we need it just like we've got the TriMag as accurate as that, because what we're trying to find out is by how much it depletes over perhaps 12 months. And you know, like I say, guys, you know, going back to the TriMag data, I think we've had a real great result. You know, we're at the end of a solar cycle, and we've seen, you know, some changes to the, you know, the measurements that we take at this observatory. And, you know, guys, that is really down to you guys. You crowdfunded every step of this. All as I've done was invested my time for you. You know, so for all those people that have made, you know, a little contribution here and there, this is where we've got to this point. And, you know, I'm going to keep investing my time in it. As long as people invest a little bit of their money, you know, they when they're on other websites or channels on YouTube, you know, they want to mention just what we're doing here. If there is a topic closely related to what we're doing, maybe there's more people that will show an interest, and we'll grow it wherever it will go is, you know, open. I'm just prepared to put more time into this. Keep collecting the data. Like I say, next month is our first year's anniversary. 9.6 million readings over the year. 12 months worth of data already collected and archived and on there, free to everybody. And, you know, why shouldn't it be? So guys, I'm going to say what I usually do, but before I do, there is a link down there if you want to keep supporting our efforts here. And, you know, you've got your weekends ahead of you, and, you know, enjoy it as best as you can, and we'll be back perhaps over in a few days' time. And again, big thanks to everyone that supported it. Okay, bye for now.